We got 1 more minute and we're going to get started. Just going to be patient and wait for everyone. Well, again, thank you guys for joining in. Hopefully you guys can see what's going on. If you guys want to comment in the sections below or on the side in the comment section, feel free to. I do have some colleagues online right now, so don't feel bad if you're going to ask the questions. We have people standing by to help with the answers. Thank you guys again for joining in to one of our demos for the grid tool and for stitch mode on the dolphicam2. We just wanted to thank you guys very much for taking your time out of the day to stop by, even if it's afterwards, after the live feed. We just thank you guys for coming by our channel. Please remember to subscribe as always. Also, please visit us at www.dolphitech.com, or you take a look at our portal page, portal.dolphitech.com, as well as you can find us on Twitter, of course, here on YouTube, and then again on LinkedIn. So thank you very much, and we're going to go ahead and get started. So if you guys are unfamiliar with the dolphicam, I'd like to at least start off by explaining a little bit about the dolphicam and its capabilities. The dolphicam is a 2D matrix array ultrasound system. It's capable of longitudinal beam only, and so therefore it's very much like a thickness tester. And so but has very high resolution. The transducer here that you see is a 128 by 128 element transducer. It provides 16,384 active elements. So you heard me correct, 16,384 active elements. We are slightly different than your standard piezoelectric transducers that you find on the market today. So, but you can find more information about our transducers on our portal page. So thank you guys again. The grid tool is a very simple tool. As you can kind of see, I apologize. I'll play around with the webcam a little bit. But as you can see here, it attaches itself to whatever surface that you would like to inspect. So in this case, I'm going to be inspecting a piece of stainless steel tank that was taken out of service. It had stress corrosion cracking. This piece does not. However, I did simulate some corrosion on the backside as well as some pitting. But as you guys well know, that ultrasound finds itself useful to some of the damage mechanisms that are convenient for longitudinal beam. So you will notice that there is going to be some areas that we do not get a clear reflection back. But you will see what the results look like when we go into our live mode and stitch mode. So we're going to get started. Again, the grid tool is just a quick little device to set up and make it easier for you to maintain your distance to capture and stitch all the images together. So we'll get started on the setup. For the most part, I'm already set up and established. But I'll run through. If you cannot see, I apologize, but we'll go ahead and get started on setting up. So first things we're going to do is go into our transducer, and we want to adjust our gains. We have our time of flight and our amplitude-based C-scans. And as anything, you want to make sure that you have a nice, good coupling. As you can see here, this is your front wall echo or your interface echo, and we're going to pay attention to this because that's where our sound is coming into the part, into your B scan. This is your C scan. Here you have an A scan view as well. And then you have another horizontal B scan here. So we're going to adjust our gains to make sure that we have good contrast and we get good reflection on our A scans. and which we've already adjusted. And then we have our transmitting elements. We can adjust the amount of energy that is going into the part to give us better detectability and resolution. And so as you can see, you start intensifying the signal here by increasing the number of transmitting elements. We're going to go ahead and let's try 4. I like 8 better. So we're going to adjust it to 8. Then we have a few other signal averaging. I have it set to 4. It's a good in between. You know, we increase our scan speed when you decrease your sample rate. So you know, you can scan much faster. Then what we're going to do is go into our coverage, and we will take a look at our delay. So this is where the interface gate is, and we're going to adjust that because it's kind of coming right at 0. So let's adjust it so 0 is right at where the interface where we start, you know, the sound starts attenuating there from the reflection. So we're going to drop that, and then we're going to go ahead and go to our range. This piece is about roughly 5 millimeters, and here's our back wall right here, right at 5 millimeters. If you needed to change the velocity, we have a velocity chart inside of our menu, and then you also have your gates. So if we go into our gates, the nice thing about this is gates are pretty simple. That you just adjust them on your B scan for what part of the substrate you want to inspect, and then you have a front wall gate and you have a back wall gate here. And then we have up to 3 gates that you can select, depending on if you're looking at bond lines or if you have coatings or things of that nature. So we're going to go ahead, and now for the most part, we're pretty much set up. So we're going to go straight into the stitch mode. And then once we finish with with the grid tool, I apologize, we're going to go into the grid tool and show you guys what that looks like first. And then we'll remove the transducer from the housing and go into live stitch so you can see what the view looks like in real time just in the C-scan, as opposed to capturing all the information in a large stitched area. So we're going to go ahead and get started on stitching. And this is our designers made this very simple for users, meaning that we start off with a blank template here, and you can adjust it by increasing the number of squares that you want to add to it. You can decrease it. You can go height, width. You can adjust your stitch pattern here. So if you want to go right to left, top to bottom, zigzag, zigzag left to right, zigzag up to down. It doesn't matter. We have all the options there. We even have camera rotation. So depending on the direction in which you want your camera to be angled, you can select the type of camera position that you want it. We're going to stick with 1. Then we're going to, you can come in here and adjust. We have preset inspection area sizes. So if you want to adjust that there, or you can just put in your own size. You can create your own custom grid. So we're going to go then into overlap, but because this is in manual mode. Now, when you go into grid tool, you're going to have, of course, you're going to be limited. So the grid tool has basically little markers on the rails here, on the guide rails. And so those markers are preset distances apart from one another. So it makes it easier for your technician to know exactly what those distances are, and you always get a consistent image on your screen. So, and that's where we're going to start here. We're going to go just simply left to right. We're going to look in the amplitude C-scan. You can change your stitch to time of flight if you wish, or amplitude. And then the other nice thing is that when you're on the tough pad, the screen's fairly small, and then if you can imagine that these squares are even smaller. So the nice thing that our guys put in here was a pop-out window in order for us to see a larger view of what we're looking at instead of having to stare, and strain our eyes on these smaller squares. So this little active image here is very convenient for users. So, okay, so we're going to get started. We pretty much already have everything set up. I've already placed my coupling on there, and I'm going to get started. So just so you guys can see, I'm going to add a little coupling underneath there, plop it down. We have our suction cups to make sure that these are secure. Of course, you can add, other, if you wanted to design anchor points, such as instead of using suction cups, if you wanted to use magnets, things like that, so it's a little bit easier or more convenient for what you're inspecting, feel free to do so. The nice thing is that just standard mechanism that you want to bolt it to the rail, the guide rails. So we're going to go ahead and get started here. So all you do is there's a button on the front of the TRM. And as you can see here, here's a little button, and this is what's going to activate the window, and then you press it again to store the image. So as you can see, I'm going to activate it. After I move it, I'm going to adjust it one. Okay, and then activate it, which turns it on, capture it, activate, capture. I know this is the fun part for you guys to watch, right? All right, last square. There we go. So now, as you can see, we've built the entire stitch. Then we can come in and we can go into, I'll close this active window here. We can go into our sizing tools, and the sizing tools make it very nice and easy for technicians to determine what type of or what size that damage is. So if you can come in here, I know it's a little difficult for you to see, but you can draw from the things from working from home. I apologize. So you can measure from one extent to the other extent, and as you can see here, this is saying this is 83 millimeters long, and then if you need to know the total width or height, this is 50 millimeters tall, and so you guys can put that into your API calculations. Then you can switch between amplitude to time of flight. Of course, you can see here the different gradients and scale to see what the damage mechanism looks like, what type of corrosion that you're seeing, and that's pretty much it. You do have area, square area. So if you wanted to know the overall affected damage mechanism area here, then you guys can resize this, determine exactly how big this flaw is. Again, put that into your API calculations or any other calculations that you're working with, and to determine what type of repair is necessary or how to move forward. Like if you were working with piping, maximal allowable pressures, you'd have to figure out that calculation as well. So hopefully that was a little beneficial for you guys to show you guys how easy and fast it is and the good results that you do obtain using the grid tool. Now we're going to take a second real quick to detach the probe, and we'll just do this manually. So give me one moment. Let's see, how many companies are using these? One of my colleagues should be able to answer you guys on there. We have quite a few companies that are across the world. We have a lot of people here. I believe many of you guys that are joining us here today are from the UK region, from the Composite Forum. So thank you guys for joining on. I appreciate you guys being here. Thanks, Warren, for helping us out as well. We look forward to partnering with you guys and many of you guys, the other folks that are there watching online. So, we have several companies that use the dolphicam across the world, as I mentioned, from aviation, space exploration, and automotive industries. But we'll be more than happy to share with you more information. If you guys could leave us contact information, or you could reach us on our contact page as well, and let us know what your application is, and we can divulge some more information privately to you guys. So thanks for your question, High Peak. Appreciate it. So we're going to go back into our live mode now. Like I said, hopefully you guys liked what you see there with the stitch and the grid tool. It's pretty effective for what you need it for, especially when you're dealing with things that are, underneath, or if it's hanging vertically. When it's flat like this, it's pretty easy to inspect. But when it's high up and it's, like a windmill blade or underneath of a fuselage or on the side of a tower or tank, using the grid tool makes it a little more beneficial for your technician to be more accurate when acquiring data. So now we're going to go into just the live stitch mode where it's more manual, and we'll get that set up for you guys here in a second. And let's see, let's go to manual. Again, I apologize about the contrast here. Unfortunately, the webcam doesn't have the ability to adjust. So there's some data here that you guys are missing, but hopefully you guys can get the gist of it. So we're going to go into A-scan. We're going to go into live. Now I want you to see what this area looks like when you're just scanning this. So hopefully you could get a better view there. You can see that everything is real time. You don't have to just capture that data. So we can store this information we can evaluate this information as we're scanning across the material. So as you can see, every time that I move, the data is changing real time, right? So it makes it very easy for us to locate the damage mechanism, determine the size of it, because if we know that area of interest is extending outside of the limit, well, then we know that it's larger than the size of our TRM here, which is about 30 millimeters across. So that way, right away, you can determine, okay, well, what is that size? And then, of course, we have our scale here on our screen that also is convenient when sizing. And then, so as you can see in the B scan here, you can see the back wall echo adjust and move forward as well. And the other nice thing about that is, I know I'm going a little bit outside of what we were initially going to talk about, but the nice thing is that we can come in. I want to show you guys real quick just how fast it is to size a damage mechanism that it appears in the B scan. So right there, it's telling me it's about 4.5 millimeters, almost 4.5 millimeters deep. So, and then of course, time of flight as well. So there's your time of flight view. So we're going to go back into manual stitch. And I'm going to delete this. There we go. And one thing I will show you guys with the dolphicam that I failed to do with the grid tool at first, which was when we're collecting the data, the nice thing about this is it's very convenient. Like many systems that are on the market today, when you're capturing data, you have to record again. You can't just go back, right? Because it's a single line encoded, or it's a raster scan. So, or you have your XY, and you have to find that beginning point dead on. Well, if you already have a grid in there, and with the dolphicam, once you go live, you can go into your area of interest, and I'll show you guys here that if you make a mistake, well, then I can just simply come in and see, I moved my probe before this one was finished. So I got to re-record this. Well, instead of just sliding backwards like an encoded, I can just click on, sorry, one of my other tools was activated. I can just click on this and there's a red square now around it saying that that's live. So I can just go back to that square and say, okay, well, I want to re-record over that and get a better signal. And there you go. So you can go through the entire grid and see or capture that information first and then go back to whatever square you need to. As you can see, it's pretty quick when you're doing it manually. And again, there's the information. So you can see that there's more flaw, more damage over here that is not being collected, but it does extend out there. So what I would want to do is say, okay, well, if I want to now capture that, well, I can go up here and easily go in, add another row, click this column, and now come in here and finish capturing that data. Oops, step over. Let me come down here. And there you go. So now I have the whole area of interest, whereas before I was missing this data that's over here. So it makes it very easy. And then we even have like a diameter tool to bring on board. So if you wanted to know the diameter of this flaw, you can come in here and put it right over the size, and it'll give you the affected area in diameter. So hopefully, and again, you can switch back and forth between time of flight if you want, or amplitude. And then the other nice thing about sizing is, you know, when you guys are scanning, we have these dynamic points that make it very convenient to size as well. So when you go live and you scan into your damage, as you can see, there's these flaws are actually giving me depth measurements right away and where these dynamic points are. So you have almost 5 millimeters, and this one's reading 1.2 millimeters deep. So we have a multitude of different measurement tools as well on board that make it very convenient and helpful for you guys. So I hope you guys liked it, and thank you guys very much for your time. If you guys have any more questions, I'll be more than happy to. Oh, wait a second, hold on. We got, hey Brett, what happens if you overlap the measure? Jesus. Well, as I mentioned, if I'm reading your question correctly, if you overlap, then you can just easily go into the stitch. Let's go back into stitch mode. And the nice thing is if you come in here and say if one of these squares had a better image than the other one, you can bring this one to the front, and you can bring this whole entire row to the front, Jesus. So if I'm answering your question correctly, as you can see, if you made an accident and you overlap, or if this is out of alignment, well, then I can go into this square right here, and hopefully I can find, I think it was this one. Yeah, it looks like that one right there. And it looks like I was right about here. So now I can improve that scan and get a better image and align that up. So hopefully, if that was what you were asking, Jesus, hopefully I can answer that. If not, we can always take it offline as well. Let's see. Is it scalable? So if it is, okay, thanks, Jesus. Is it scalable? So of course you can change the size, whatever size you want we have a feature here which is overlap. So of course, whatever you're overlapping, if you want to make it as small as a 1/4 inch, you can make that area of interest as small as you want. And of course, and also we have on our TRM, we have an area that is, let's see, let's go into signal and imaging. I'm sorry, coverage. I apologize. Transducer area. And then we can go into and change the size of our transducer area here in order to display a smaller area on our transducer. So currently the software is designed to start from the edges and work its way down. So, but we are going to look at adjusting the software so that way you can, tell it, customize it exactly what quadrant of the transducer you want to measure from. Do we want to measure from the upper left, upper right, lower left, lower right, or do you want to just keep it right in the center? So hopefully that answers that question on the scale. What about the surface preparation? Is it like normal UT? Yeah, this is very similar to normal UT. There's nothing any different. It's the same physics. So yes, the answer is yes. Let's see, a couple hundred. Okay, there you go. Thanks, guys, for answering that question, Anders. Appreciate it. I would like to introduce this to Dr. Perfect. Thanks, High Peak. We would love to introduce this to anybody that you guys have to consider. We appreciate the leads. Thank you very much. How portable? Okay, so let me go ahead and grab. So if you've not seen the system in its entirety, this is it right here. So here's your dolphicam. I have it on my TV. That way I can show and share the display, but this is kind of difficult to look at on a small little camera, right? So, but what we have here is the black box on the backside, which has, and I'm getting ready to post a new video that goes through a lot of this as well, guys. So you should be seeing that here on our channel here soon. But you have your 2 encoder inputs here for X and Y. You have your network cable, your charger. You also have your USB-C for your data, transferred data. You have on the tough pad, you have a USB and HDMI and an auxiliary for your audio. You also have another USB up here on the top. And then you have your 2 transducer ports here because we are currently, you can only use 1 transducer at a time, but we are looking at creating like through transmission capabilities or pitch catch even down the road. So we have a lot of things that are going to be coming up that are going to be beneficial to a lot of the users. Eventually we are going to scale up, ladies and gentlemen, to get to the point where, we're very competitive to the conventional, I call now conventional phased array systems that are on the market today. But right now, we're a great screening tool. We get the data very quick and effectively, high resolution. Not much is unseen, so to say. And so, we can even see. I've had results of identifying cracking, vertical cracking. Right, it's not typical for a longitudinal beam to detect a crack, and but you can see those in some extent. And so there's a lot of things that are going to be coming up, guys. So just please keep watching, keep in touch with us here at dolphitech, and you're going to expect really good things here coming up within this new year in 2020. So let's see what else. What about the surface prep? Okay, yeah. I think that's everything, guys, gals. I appreciate you guys, coming and joining us. And I look forward to hearing back from you guys down the road. If you guys want to get in touch, please reach out to us. Of course, you can email me at brett@dolphitech.com or, again, the Get in Touch tab on the Dolphitech website. We would love to have you guys swing by and take a look. There's more data on the portal page at portal.dolphitech.com. And again, follow us and like us on our Twitter, YouTube, the LinkedIn. And so we thank you guys for everything that you guys do. We look forward to hearing back from you guys again soon. All right. Take care.